I've made this translation I variable a private instance variable. Now, this is not a property for reasons that I'll wave my hands at for now, but realize for today's purposes, a cautionary tale, be careful trying to represent structs with properties. Things tend to break, and Xcode will often yell at you. And the quick teaser for why is that if you've got a property called foo, and you want to access it, you would access it via this mechanism here, self.foo, if that's a property called foo. Now suppose that foo is a struct, like CG point with an x and y field. Well, back in C, how do you access the members of a struct? Dot notation. So you might say foo.x. So this looks completely reasonable, and in fact, this would work OK. But suppose that you want to do something like this, self.foo.x plus 1. Suppose you want to move the thing over 1 pixel. So now this doesn't actually work. Why? Because you have to go back to the basics of what a property actually is. Self.foo is just syntactic sugar for what? Passing a message, exactly, called foo to self. Now, a struct is effectively a primitive, right? It's not itself a pointer. A struct is a struct. And think back to C. Whenever you call a function and it returns some value, if it's not a pointer, it's a value, and values are passed by copy. So what are you going to get back when this message returns a value? You're going to get back a CG point, but a copy of a CG point. So that when you then say .x, that's fine. You can access the x coordinate. But if you then try to assign it to be some other value, you're wasting your time. Why? Because you're just updating the copy. And so understanding the underlying details of implementation here is super important, because on one hand, Xcode will yell at you. And so if worst case, you'll just scratch your head as to why you can't do this in iOS programming. But this is actually the reason why, because you're actually calling a function and it's returning a value, but it's returning a copy of a value because of the way the stack frame works. And so you can't actually mutate that x value purposefully. It's just going to be changing a copy, which is a useless exercise. So in short, beware of representing structs, which CG point is, as anything other than a local instance variable. All right, so now scrolling down, we've prepared Tommy. I've got a handle pan method. I've got a handle pinch method. I've got view did load. Let's look there then. So again, when reading through someone's UI type code, start with the app delegate, move on to an init method, then look for something like view did load. So what do we have here? Same code as before. I'm listening for a pan or I'm listening for a pinch. And so this code is structurally the same as before. I'm saying inform me, self, specifically passing in the handle pan message or the handle pinch message. And how do we do this? Well, now unfortunately there's some math involved, which is sort of interesting, but besides the point for how the code itself is designed. So we'll wave our hands at some of these details. But this is how we now start doing, these sexy sort of capabilities of these devices. So if handling a pan, so if I want to translate Tommy, that is shift him right, left, up, or down, I have to actually start doing some math here. So in order to figure this out, for today's purposes, let me go ahead and wave my hands at this, but point out some of the salient structures. So we have a CG affine transformation struct here. We have a CG point. We have this helper function here, transformation concat, to actually concatenate, essentially do matrix multiplication. If this is unfamiliar or completely rusty, don't worry. It's doing transformations essentially follows this kind of boilerplate code. But ultimately, what we're trying to do is shift Tommy's location by some number of points on the x-axis and the y-axis. And we can figure this out by asking the sender, and let's see where we use sender in here. We can ask the sender exactly what the shift has actually been. So in other words, we're passed a pointer to this recognizer. The recognizer is going to inform us how far the human finger dragged, and we can then use that to infer the mathematics of translating Tommy as a result, so that he effectively follows our finger up, down, left, or right. And pinching is very similar, but instead of translating him, we're instead going to update his scale and thus the size of the image that's actually being displayed. All right, but more fun than scaling Tommy is to actually implement something like Pong, which I promise you 30 years ago was a really cool game. So let's start with these last of two. Let's implement a little paddle. So this is a little paddle example that's not going to do a huge amount of interest, but it does implement the first application where we're not actually doing just standard UI widgets. So if pretend the arrow is my finger, I now have the beginnings of a game called Pong. And for those unfamiliar, there's going to be a ball eventually that's going to bounce left to right, top to bottom. And the goal is with these white paddles to make sure it doesn't pass your goal. Otherwise, you lose a point. So there's something interesting going on here where I'm detecting the key press. And I'm actually translating the position of this little rectangle to match whatever that is of the arrow. I'm apparently ignoring left-right movement, but I am responding in lockstep to up-down movement. So let's see what's going on here. Well, notice in my nib file for this paddle example, all I've done is create the background here. I just made it black, and that's it. Because I decided here that I don't want to use a static image for the paddle. I can draw it myself. And indeed, we can see how to draw something as follows. I went ahead with Xcode's file menu, and I created a new object, an NS object, or rather a UI view object, which descends from NS object, and I called it paddle view. So in other words, my goal was programmatically to implement a Pong paddle, to draw a rectangle with core graphics. So I have my H file, and thankfully there's really nothing interesting there to worry about. But if I go into my M file, notice that this is how I can fairly simply draw on an iOS device. So much like in Photoshop, the world of iOS is modeled in terms of rectangles, pixels and x-axes and y-axes. And it turns out that inside of a UI view, if you're not using a nib, a drawRect method will get called automatically when that view is created. So in other words, when I instantiate a paddle view, this method drawRect will get executed. And its purpose in life is supposed to draw something on the screen. So how does this work? Well, CGRect is another struct. I can hover over this thing with Option, and you'll see that it has an origin inside of it and a size. So that's what defines a rectangle here. And there's this little helper function that allows me to make a rectangle. Specifically, it's going to make it at location 0, 0, so in the very top left-hand corner. And it's going to make it 10 points wide. And it's going to make 60 points tall. So roughly 10 pixels by 60 pixels, though it does depend on the resolution of the screen. So in this case, I now have a rectangle. I want to make this thing white. Well, it turns out there's a UI color class, and I can very easily set things to white for this rectangle just by saying give me the white color and set it. And now notice I'm calling UI rect fill. I want to fill the square that I've just constructed with whatever color I've decided on. So in other words, line 1 creates the rectangle. Line 2 picks a paintbrush out of the available paintbrush colors. And line 3 actually paints that rectangle on the screen for you. So what's interesting here? We're really actually mixing two different languages, right? Line 1 is what language? C. Line 2 is Objective-C. Line 3 is C. All right, so again, Objective-C is layered on top of C, and indeed, a lot of the underlying core graphics routines, a lot of the low-level mechanisms in iOS are still written in C, partly for performance again, partly for other reasons. So understanding the syntax, which is essentially the same, except you don't have object-oriented features in the older style C code. All right, so that gives us our paddle. What actually gives us the dynamism? Well, we can do this. So notice that I've done this here. Let me wave my hands at this a little bit, just so we don't get too distracted. Here's my init method for the actual game. This is the view controller. Notice at the very top line, I'm allocating a paddle view, and I'm giving it an init with frame message that's saying 10 by 10 by 10 by 60, which is just giving it a region of the screen to operate within. And then I'm effectively having it draw itself within that region, a sliver of the screen on the left-hand side. And then what is the second and final line there doing? Self.view, add subview. Well, GUI programming, at least in iOS, is entirely about hierarchy and layering one thing on top of another. So you recall in Interface Builder, when we've been dragging and dropping things, recall that they start creating a hierarchy of things on the left-hand side, where you can see that the table view has this button, or rather this UI view has a button inside of it. There's a text view inside of it. So in other words, you're layering widgets and widgets on top of one another, on top of some kind of canvas. And this second line of code there is essentially saying add this rectangle to the existing canvas. And that canvas, by default, is known as self.view. So that's the default rectangle that initially is white. When we do nothing in our application, the add subview is layering something on top of that. Or in this case, I made it black by tweaking the nib. So how do I now respond to the user's finger? Well, it's actually relatively straightforward. I have to implement this special method called touchesMoved with event. And now I simply have to get some details from that object and then move the paddle's location in lockstep along the y-axis. So on the left-hand side here, I have a UI touch pointer, and I'm saying give me all the touches that just happened on any object. This is actually a simple application. I don't have to worry about multi-touch. So wherever the user touched, that's the one I care about. So that first line gives me the touch that just happened on the screen. In the second line here, I need to know where did the user